In this lesson, we're going to talk about the quadratic formula and the discriminant. The first thing we're going to talk about is the discriminant. You can see here the formula for the discriminant is b squared minus 4ac. You'll also notice that the discriminant is located within the quadratic formula. It's found underneath the radical sign. It doesn't include that radical sign, it's just found underneath. What the discriminant does is it tells you how many roots there are for the quadratic equation that you're given. So sometimes when you calculate that discriminant, you'll have a negative number. And what that means to have a negative discriminant is that you're going to have 0 roots to your quadratic equation. The graph is not going to cross the x-axis at all. Sometimes your discriminant will actually be the number 0. And if it's the number 0, that means that it's going to cross the x-axis just once. And if you have a positive number underneath that radical sign, that means that your graph is going to cross the x-axis twice in 2 different places. So that's what the discriminant actually means. And it's very important to note that when you're calculating the discriminant, you must have your quadratic equation in standard form, which is ax squared plus bx plus c is equal to 0. That is very, very important to calculate the discriminant correctly. So let's go ahead and try these 3 problems. It says state the value of the discriminant and determine the number of roots. So looking at this first example, we need to ask ourselves, is this problem in standard form? And the answer to that is yes. So let's go ahead and determine a, b, and c. A is going to be represented by the coefficient 4, b is going to be represented by -2, and c is going to be represented by our constant, which is 14. Once I identify my A, B, and C, I can simply go ahead and plug them right into my discriminant formula. I always like to use parentheses whenever I'm substituting things in. So let's go ahead and do B squared minus 4 times A times C. And you can simply plug this entire expression right into your calculator or Desmos. You can go put it right in there. Just remember to have your parentheses. And the value of my discriminant comes out to be -220. So that is the value of my discriminant, which also tells me that there are 0 roots to this quadratic. This quadratic equation is not going to cross the x-axis. Let's try another one. Looking at the second one, I have to ask myself, is this in standard form? And it's not. So let's go ahead and I'm going to move everything over to the left-hand side. So if I do that, that's going to leave me with 3x squared plus 10x minus 12 is equal to 0. And all I did was move those variables around to get them all on the left-hand side. Now I can identify my a, which is 3, my b, which is 10, and my c, which is -12. And once I have those values, let's go ahead and plug it into the formula. So I have b squared minus 4 times a times c. I'm going to go ahead and put that in my calculator, and that's going to give me a discriminant value of 244. Since it's a positive number, that means that tells me that this quadratic is going to have 2 roots, which means it's going to cross the x-axis in 2 different locations. And then essentially where we're going with this is we're going to be solving the quadratic formula, which is going to tell us the exact location of those 2 roots. Okay, and the last one here, we're not in standard form, so let's go ahead and quickly put us in standard form. We have 9x squared plus 12x plus 4 is equal to 0. I'm going to go ahead and calculate my discriminant. My A is 9, my B is 12, and my C is 4. Let's go ahead and put it into my formula now. B squared minus 4 times A times C. And if I put this into my calculator, the value of my discriminant is 0. If the value of what's underneath that radical is 0, that means I'm going to have 1 root, which, if you remember correctly, when you have one root, that's also called a double root. Okay, so that's how you determine the discriminant. All right, now I want to take a look at the quadratic formula. So while you're calculating the quadratic formula, you're going to be able to tell how many roots you're going to have before you even calculate what those roots actually are. So let's go ahead and take a look at why we actually use the quadratic formula. Now, this is kind of important here. So we've already kind of talked about this, but why do we use it? Well, of course, it's to find the exact location where those intercepts are on your coordinate plane. But the other reason is because some quadratics are harder to solve using other methods that we've learned, such as completing the square or taking the square root of both sides or even factoring. Sometimes the numbers that you're given in your equation are just difficult to work with. So the quadratic formula is kind of like the formula that we go to because it's really easy to kind of manipulate it. So your go-to method should always be the quadratic formula. Now, I also want to show you, look at these two examples at the bottom. I have two quadratic equations, and one of them, the one on the left, has integer roots. So roots that are really nice roots. They cross the x-axis in a nice location. Where the other one, you can see, look at these other ones. These other ones lie between two integers. So you can see that those ones on the right-hand side, these are actually going to be answers that are decimals, or we could also write them in simplified radical form, which is what we're going to do today. So the quadratic formula is really helpful for the ones, for both of these situations, but definitely very much so the ones on the right-hand side. All right, let's go ahead and calculate our first problem here. All right. The first question we have to ask ourselves is this in standard form? And it is not. So let's take a second and put this in standard form. If I do that, that's going to leave me with 3x squared minus x. And then I'm going to move that 7 over, and that's going to give me minus 2 is equal to 0. Now I'm in standard form. Now, if I wanted to, I could factor this, or I could complete the square, or, I could use another method, but I'm going to use the quadratic formula to kind of show you how to use it. Let's identify A, B, and C. My A is going to be 3, my B is going to be -1, and my C is going to be -2. And I just captured those right out of that equation. All right, let's go ahead and plug it into the formula. X equals negative b. Well, that's going to be -1. And don't simplify it quite yet. We'll simplify it at the end. Plus or minus the square root of b squared minus 4 times a times c. And that whole thing is all over 2 times a. All right, the first step is to plug in all the numbers. Now, the second step here is to simplify. So be very careful when you're simplifying things. So that's going to equal 1 plus or minus. Now, let's go ahead and calculate the discriminant. You can put that discriminant, which is underneath the radical, you can put that right in your graphing calculator or Desmos and just crank out that number. And I get the number 25. Now, you might feel the urge to simplify that. Just hang tight. Divided by 2 times 3 is 6. Take each step very slowly and simplify. Let's go ahead now and simplify that radical. So I have 1, and then I have plus or minus. The square root of 25 is 5, divided by 6. All right, now here is where you're going to get your roots. The discriminant you can see up here. Let me go ahead and show you the discriminant. The discriminant is this number right here, 25. Which tells me that we're going to have 2 roots. So looking at the problem, here's how you're going to determine your 2 roots. I'm going to take 1 plus 5, which is 6, and then 6 divided by 6 is 1. So one of my roots is going to equal 1. The other root is going to be using the other operation. 1 minus 5 is -4, and -4 divided by 6 is x is equal to -2/3. 2/3. And those are the two locations in which your graph is going to cross your x-axis. Okay, that's our first example. Now let's go ahead and look at a little bit more challenging example. All right, looking at this next example, we're going to have a different type of answer for this one. So let's go ahead and take a peek here. All right, standard form, that's where we start. Let's go ahead and just kind of flop this around to get this in standard form. So we have 5x squared minus 12x minus 18 is equal to 0. Perfect. Now let's go ahead and identify A, B, and C. Okay, my A is going to be 5. My B is going to be negative 12, and my C is going to be negative 18. Make sure you grab those operations that are out in front. All right, let's go ahead and calculate using the quadratic formula. X equals negative B, which is negative 12, plus or minus the square root of B squared minus 4 times A times C. And this is all going to be divided over 2 times A. All right, my next step is to simplify things down. So let's go ahead and do that. 12 plus or minus the square root of, I'm going to go ahead and calculate my discriminant. And my discriminant comes out to be 504. All right, and that's going to be divided by 10. All right, I kind of have to pause here because this one gives me a little bit of a different answer here, but look at my discriminant. My discriminant is 504, which means that I'm going to have 2 roots as my answer. So I'm going to have 2 answers here. But you're going to also notice that 504 is not a perfect square value. So I actually kind of have to go off to the side and simplify it. So let's go down here and just simplify the square root of 504. I can use my calculator, but that's going to end up breaking into square root of 36 and the square root of 14, which I can simplify further to give me 6 root 14. So I'm going to go ahead and take 6 root 14, and I'm going to go ahead and replace it. So let's go ahead and do that. I'm gonna write it over here now. X is equal to 12 plus or minus 6 root 14 divided by 10. Kind of looks like a funky answer here. So there is one more step here before we finish. Now, we're almost done getting to the answer here, but there's one last part. Now, when you end up with an answer that looks like this with a simplified radical in it, there is an extra step. You have to look at these 3 numbers, the 12, the 6, and the 10. And if you can simplify all 3 of these numbers, meaning are they all divisible by a number, you can simplify them, which they're all divisible by 2. So we can actually take this and simplify those 3 numbers by 2. Here's what it would look like. I would divide the 12 by 2, which is 6. I would divide the 6 by 2, which is 3. The root 14 stays the same. And I would divide 10 by 2, which would give me 5. And you can only do that simplifying process if all 3 numbers are divisible by a certain number. If 2 of the numbers are divisible, but the other one isn't, then you cannot do that little process that I just did. So it has to be all 3 numbers. And this is going to represent your answer just like that. Now, if you wanted to, you could actually write this twice, but it's not necessary. But you could write it like this. You could say 6 plus 3 root 14 divided by 5. You could absolutely write it like that. And then the other one, which would be 6 minus 3 root 14 divided by 5. That is perfectly fine. It's basically writing the same thing, just in a different way. Now, you could also, if you wanted to, you could write this as a decimal. Not necessary, but if you wanted to, you could. And this first decimal with the positive root would be about, we'll just say about 3.4. While the other one would be, let's go ahead and see here, it would be about negative 1. We'll just say 0.04. So you can see that this is its simplified radical form, and then this is its decimal form. So these are two locations where the graph is going to cross the x-axis between two integer coordinates. And it's going to obviously look a little bit different. But I wanted to kind of show you an example of this. All right, I do believe I have one more example here today. And let's take a look at this one. Now, this one, we have to start by putting it in standard form because it is all over the place. So you will have to do a little bit of combining like terms, it looks like here. So I'm going to go ahead and start by putting x squared. And then I'm going to move that x over on the right-hand side. I'm going to subtract him over, and that's going to give me negative 6x over here. And I'm also going to go ahead and I'm going to subtract 12 on both sides, which is going to give me positive 1, and that's going to equal to 0. All right, now we're in standard form. Let's locate A, B, and C. A is going to equal 1, B is going to be negative 6, and C is going to equal 1. All right, let's go ahead and plug it into our formula. X equals negative B, so negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 all over 2 times 1. All right, everything's plugged in. So let's go ahead and calculate it out. So I have 6 plus or minus. Let's go ahead and calculate the discriminant. The discriminant ends up being 32 divided by 2. Now, you'll see that that discriminant, again, is a positive number, so that's going to say that I'm going to have 2 roots here again. You're not always going to have 2 roots, but for these examples that I gave you today, you're going to. All right, you can see that our square root of 32, again, is not a perfect square value. So we have to simplify it down. The square root of 32 can break into root 16 and root 2. Which of course breaks down into 4 root 2. So we're going to take 4 root 2 and we're going to go and replace it. So I'm going to rewrite that over here. 6 plus or minus 4 root 2 over 2. And to simplify this again, remember I have to look at those 3 values. Now they're not always going to be able to simplify, but in this case they are. So let's go ahead and simplify. This is going to simplify down, but they're all divisible by 2. So we can simplify it down into 3 plus or minus 2 root 2 over 1. And of course, we want to take this one more step and we want to simplify this because we don't want to leave the 1 underneath. That just kind of looks silly. So your answer here will be x is equal to 3 plus or minus 2 root 2. And that is where your graph will cross your x-axis. And of course, you again, you could, if you wanted to, you could write this in 2 different ways. You could say that x is equal to 3 plus 2 root 2. And then you could say that x is equal to 3 minus 2 root 2. If you wanted to do that, that is perfectly fine. And you could also go ahead and grab the decimals, which our first one would be about 5.8. And then our other one would be about, let's see here, 3 minus 2 root 2. That would be about 0.17. So again, you could write it as a simplified radical or decimal. It doesn't matter. But the thing to know is that these are non-integer coordinates. So they're going to lie between 2 integers on your x-axis. And that brings us to the end of our lesson on the quadratic formula.